This is the final project submission for ICT 428, Computer Vision and Augmented Reality, Section 130. My name is Agatu, and my name and my student ID will be shown here in post-production. The core idea of this project is based on weeks 12, Vuforia image target, slides, and lecture. So what we have here is two image targets with two child objects. These are just standard 3D models of a cat, and I attached a script, a very simple script to them that makes them spin around. So for this project, first of all, you have to go to the Vuforia's engine developer portal and get the package download, but that was already covered in class. Also, additional stuff you have to do includes going to target manager. You can give whatever name you want, and you have to add targets. I decided to add 2 targets and perform like 2 image targets simultaneously. You then put your images. So here for these, I just try to find targets with 5-star rating. So after you upload the targets, they tell you like how good it is to track. So ideally, you want to find targets that have very contrasting edges and unique features, so that when you spin it around and stuff, the engine can still detect its position. After you do that, when you download the database, you want to make sure you pick Unity Editor. This is because we were taught to use the Android app deployment during class, but I don't have an Android device. I tried enabling the developer option for my iPhone using the iPhone Care like root package. So I think it's here. Oh, sorry, iCareFone on this computer. But then I ran into some trouble later on because you have to get like security certificates and stuff to install apps into your phone. So I just decided to try to run it on Windows with my webcam. I have a webcam pretty similar to Ajahn Pong's webcam, so it should work pretty well. And here the pictures are downloaded. At first I tried to use a QR page, but they did not let me use it. So I changed it to something with more rounded edges. And then we also have to get the license key. So we just generate a basic license key, and then we just keep it in Notepad for now. Create a new project with your student ID and the description title, and then here. So I deleted the main camera and replaced it with a game object, Vuforia Engine's AR camera. But when you do that, just make sure that it's going on to, this is where you copy paste the license key. And here, I set this to 2 because I wanted to track 2 targets at once and deploy the AR projection on both of them at once. Also, make sure that this is showing webcam, and this is the webcam I'm using right now. I think it's the same one as Ajahn Pong. And yeah, you just make an image target where you assign it from the database. Oh, sorry, I forgot to mention that you have to import the packages. So we will have to import the engine package, and this is the 3D model package. Also, the last one, we have to download this database, and from the Downloads tab, you have to double-click. So this will prompt the package to be imported into the application. Okay, let's make sure these child objects are moved up from the image because we don't want it to be like placed within the image, just floating on top of the image. And for the script, I just wrote a simple script. Oh, let me open it up. Okay, so this is like Unity scripting. I'm not going to go like very in depth, but it's just a very simple script. First of all, you import the libraries, and then we mostly want our object to rotate. So we use transform. So transform defines how the object will be like positioned in space. So we want it to rotate as well, and we have to transform it by a vector. So we need to make a vector. So I made a new vector tree, and to construct the vector, we want to like rotate it mostly side to side. So it's like spinning around in a circle. So we are spinning around the y-axis, and then the second axis here. So the first is actually the x. You have to put an x first. So I'm going to put in 0. And then for y, initially I set it at a lower number, but because I wanted to replicate the spinning cat meat, I made it 1,000 so that it's really, really fast. And you need a float, so I just put .0f to make sure it's a float. And the last part is actually just the final part. So we close it off. But at first, this was bugging because there's an issue with the code. If we use Unity, we have to make sure that it's rotating on the frames of Unity's rendering. So when we call the update function, it calls it like once per frame. So right now, we can rotate this much every single frame. But we want it to rotate a lot every single frame. So then like to make it spin super fast, but my computer is like really bad too. It's like pretty slow. So I just did time times time delta time. So it means that in the same time that pass, when we call delta time, it actually like runs this as the amount of time that's passed between each frame. So technically it comes out to like the same, but we multiply it so that it will spin at the same speed as our script. So later then we just save that and we go here, we drag and drop onto each objects to assign the scripts to them. And okay, wait, I'm setting up the images. Okay. So when you run the program, okay, what we should see is that two images are targeted at once, and we are projecting and deploying an AR 3D model of a cat. And the cat is spinning because of my script, which is like script spin behavior, where initially I set it at around 50, but it was very slow. So I had to put it at 1,000. And this is emulating the popular meme of the cat spinning. And yeah, we stop the demonstration. Okay, so this concludes the project demonstration. The project's background and concept is that people these days, they don't engage with something unless it's fun. And me personally, I also want to work on projects that are fun for me so that I actually enjoy doing it and enjoy spending time and committing to the project. Thus, the midterm project being submitted earlier was actually kind of silly. And this one also carries into that ideology where kids these days, they will not engage with something unless it's fun. So we have to make it engaging and fun for them, like these TikTok filters with like mini games and stuff. You could say that this has no real world application. But to be honest, life's not all about work, right? Sometimes it has to be fun. So this one can also generate money if you happen to get this filter monetized, and if TikTok does pay you out, then this could also generate money, which could go toward other proceeds like charity or something else. And this is a solo project. So again, this is my name and my student ID, which I will add in post-processing. So every part was developed individually. The components sourced from external resources include the engine packages, the 3D model package, and the images, the target images. When I printed it out, I only had like a black and white toner printer. So surprisingly, this still works even though it's not colored. And also this one, I had to Google the solution to this part because at first it was not running properly. The part that I'm most proud of is being taught to only deploy on Android devices. I try to work around that by deploying to an iOS device. But then I just use the Windows webcam. The workarounds were that when you download the database, just make sure it's only saying Unity Editor. And then here, we actually have to add the AR camera, right? But then the AR camera, just make sure that it's assigned to the webcam. Also the script, even though the script is very, very simple for this project, it was very, very hard to figure this out. AI and stuff didn't really help that much. So you had to go back to old school methods and kind of get the help of other coders on GitHub and stuff. So in conclusion, the key learnings were that I learned to work around the restrictions that I face during the classwork in class. And then we also were taught to only project on one image target, but I managed to work around and project on two at the same time. Challenges faced were mostly in the deployment to iOS that I was trying, and then the script writing. Okay, this concludes the presentation of my project. Thank you.